Hey everyone, and welcome to today's Explainer. Today, we're unpacking the true unsung hero of the digital world, secondary storage. We are going to build a super clear framework together to understand exactly how our computers manage to save our digital lives. So whether you're cramming for a big exam or just trying to optimize your own workflow at home, let's jump right into the mechanics of storage.
Okay, let's dive into this. I want you to picture something truly terrifying. You've been glued to your keyboard for hours, right? You're typing the final sentence of this brilliant 10-page essay, and then suddenly the lights flicker and your computer screen goes completely, absolutely black. The power just cut out, your heart drops into your stomach. When your PC finally reboots, is your essay still there? Well, if you haven't hit save, the answer is a devastating no. Gone. Poof. And that visceral panic of losing your work, that right there establishes the critical, absolute need for secondary storage.
So here's our roadmap for today. 1. Beyond the RAM. 2. Hardware versus media. 3. The storage showdown. 4. The 4 pillars. And 5. Scenario matching and exam mastery. Let's start with section 1. Beyond the RAM. The necessity of storage. Think of primary memory, or RAM, like a fragile light bulb. The second the power is turned off, the data disappears instantly. It just shatters. Now, don't get me wrong, it's incredibly fast, but it has literally zero object permanence. Secondary storage, on the other hand, acts like a heavy steel vault. When you actually save a file, the data is locked away safely, remaining permanently secured inside, completely independent of whether it has a power source or not. To put this in proper technical terminology, we're talking about volatile versus non-volatile memory. RAM is volatile. The moment the electricity stops flowing, the data just evaporates. Secondary storage, though, like your hard drive, is non-volatile. It holds onto your operating system, your apps, your photos, and yes, those precious essays, permanently. It doesn't need a constant drip of electricity to remember things. Moving right along to section 2, hardware versus media. Form and function. And this brilliantly illustrates a mix-up I see all the time. To clear up two commonly confused terms, think of your storage setup like making breakfast. The storage device is the hardware. That's the toaster itself. It's the actual machine doing the reading and writing. The storage media, however, is the physical material that actually holds the data. That's the bread. You put the media into the device. So just to reinforce that distinction, the device is the hardware doing the heavy lifting, and the media is the physical material. Now, these hardware and media combinations can be internal, meaning the drive is securely slotted right into the motherboard inside your computer casing, or they can be external, those portable drives connected to the outside of your computer via a port like a USB-C cable. Okay, getting into the fun stuff. Section 3, the storage showdown, magnetic versus solid state versus optical. First up in the ring, we have the classic magnetic hard disk drive, or HDD. Let's take a look inside. You've got a circular magnetic disk called a platter, which physically holds the data, and it's spinning rapidly on a central shaft called a spindle. Meanwhile, a mechanical read/write head moves across the platter to physically alter its magnetic polarity. Now, here is a wild fact for you. That little read/write head hovers mere nanometers above the spinning disk. To put that into perspective, a single human hair is massive compared to that tiny gap. Just one single speck of dust getting in there can cause the head to crash right into the platter and completely destroy your data. Now, contrasting that super mechanical design, a solid-state drive, or SSD, has absolutely zero moving parts. No spinning platters, no mechanical arms, nothing. Instead, SSDs use flash memory technology. They rely entirely on microscopic electrical circuits that trap electrons. Because there's no mechanical arm that physically needs to move across a disk, access is essentially instant. There's no seek time at all. And without all those fragile moving parts, SSDs are highly, highly resistant to physical shocks. Drop it on a desk, probably fine. Putting them head-to-head on the specs, SSDs absolutely crush HDDs in speed and durability, purely because of those zero moving parts. But hey, don't count the HDD out just yet. HDDs remain the undisputed champions for cheap, massive storage. If you need to back up, say, terabytes of raw 4K video files on a strict budget, the HDD is absolutely still your best option because of its much lower cost per gigabyte. Let's look at a totally different approach entirely. Optical media. This includes your CDs, your DVDs, and your Blu-rays.
Instead of using magnets or flash circuits, optical drives use highly focused lasers. These lasers reflect off the shiny surface of the disk to read microscopic physical indentations, which are called pits, and flat areas called lands. And here's a really fun fact. Ever wonder why it's called Blu-ray? It literally uses a finer blue-violet laser, which actually has a much shorter wavelength than a standard red laser. That tiny, precise laser allows the data tracks to be packed incredibly close together, drastically increasing the disk's overall capacity.
Scaling up beyond just personal computers, we enter the world of enterprise storage. On the left here, we have magnetic tape. Yes, tape, like a cassette. It is incredibly inexpensive and offers just massive capacity for deep archives. But it has the absolute slowest access speed because it uses serial access, actually meaning you literally have to fast forward or rewind through the physical tape just to find your file. It takes forever. On the right, though, is network-attached storage, or NAS. Think of this as a localized private cloud for a home or a small office, where multiple users can access, read, and write to centralized drives all simultaneously over a network.
All right, Section 4, the 4 pillars of storage.
So the crucial point is that every storage media you encounter must be judged by these 4 golden rules. Number 1, capacity, the absolute maximum amount of data it can hold. Number 2, data access speed, how fast the hardware can actually read or write that data. Number 3, portability, how easily and safely you can physically move it around. And number 4, cost per GB, its financial efficiency. Let's put those pillars into practice with this master diagnostic matrix. As you can see, solid-state flash media shines with very high speed and excellent portability. Magnetic tape is the complete opposite. It's very slow, but it offers massive capacity for extremely low cost. Optical media? Well, it's highly portable and cheap, but it really suffers from low capacity. By simply cross-referencing your specific needs with this matrix, the right storage answer basically always reveals itself.
Which brings us to our final part, Section 5, Scenario Matching and Exam Mastery. If you're ever taking an exam or even just consulting for a client in the real world, just follow this simple 3-step logic. Step 1, assess the user's needs. Step 2, map those needs to the 4 pillars. Step 3, recommend the hardware. Let's try it. Take a filmmaker. They need to edit massive 4K files quickly with a team. Map it out. They need immense speed and network access. The recommendation? A large SSD and an NAS setup. What about a bank? They need to archive 10 years of old financial records in a dusty warehouse somewhere. Speed is completely irrelevant here. They need massive capacity and low cost per GB. Recommendation, magnetic tape. And how about a student taking Word documents on a bus? They need high portability and durability, but honestly, very little capacity. A simple USB flash drive is the perfect match.
Before we finish up, I really have to warn you against the most common pitfall out there. Storage is not memory. Do not confuse secondary storage, which permanently holds your terabytes of files, with primary memory, or RAM, which is volatile and temporary. Never, ever say a computer has 1 terabyte of memory when you're actually talking about its hard drive. It's a huge pet peeve for tech folks. Keep these 2 terms strictly separated in your mind, and you will navigate the tech world with so much more clarity. Wow. We have covered a lot of ground today, but I want to leave you with this final, kind of provocative thought. Your entire digital life, every single photo, every essay, every creative project you've ever made, exists only as microscopic electrical charges or magnetic polarities. It's wild to think about. If your storage fails and the power goes out, did your data ever really exist? Understanding the physical tools that anchor our digital reality is incredibly empowering. So, armed with the 4 pillars, how will you build your perfect storage setup? Think about it, and as always, keep learning.